everyone. We're going to look at how to perform a chi-square goodness of fit test using Excel. So just keep in mind that the type of data that we need for this type of test is categorical. That means it's either nominal or ordinal data. And also, when you're using or doing a goodness of fit test for chi-square, it means you have only one variable that has two or more categories. So let's take a look at the data that we have. So for our data, individuals were asked their liking for sports, right, in a class. And so if they answered 1, it meant they disliked it. A 2 meant they don't care, and a 3 meant they liked it. So first we need to obtain or ascertain how many people disliked sports, don't care, and liked. So in order to do this, we're going to say, we're going to hit an equal sign in that box. And then we're going to do the COUNTIF function, COUNTIF, parentheses. And first we need to tell it the range of data to look at. So we're going to look at all of the data here. And then let's go back up. We'll put a comma. And so then we want to tell it count if it is a 1, because these are people who dislike. And then close parentheses, enter. All right, there we go. And so we had 6 people who said they disliked it. So let's try doing that for the others. So equal COUNTIF, select the data, put a parentheses. Now we're going to say 2 because these are dislikes. Close parentheses, hit enter. And the last one equals COUNTIF, select the data, comma, comma 3, and close parentheses, hit enter. Now we want to get a sum of all of this. All right, so let's sum it up. Whoops, hit an equal sign, hit sum, type in sum, and then select all of these, close parentheses, enter. So 111. So we want, for expected values, we need to tell what we actually observed, and then we need to tell it what we actually expected to see. And since we don't really have a population to compare this to, we're going to say we sort of expected it to be even across the board. So we'll say, so in order to give it its expected, hit an equal sign. So out of 100%, we want 33% in each category of the total, right? So that would make them pretty equal, right? So let's say equals 0.33 times, and then the total. And I want to freeze that so I can just drag and drop. So I'm going to put my cursor over here in the function and put a $sign before the row letter, and then a $sign before, the column, and then a $sign before the row. And then hit enter. That'll freeze it. And now I'm going to drag it across. So you can see here, they all, for each one of these, we expected to see a score of about 36.63 for each one. Now we can perform the chi-square formula, and that's what you see here. The F stands for frequency, and the smaller 0 or O means observed, and the smaller E means expected. So that's how you kind of look at that. So to perform that formula, we're just going to kind of do it by hand for each one of these. So equals, then put in parentheses the expected, the observed minus the expected, close parentheses, and then we're going to put a caret sign. That would be above the number 6 on your keyboard. So if you shift 6 and then 2, because we got to square it. And now we're going to divide by the expected. That's exactly what that formula is that you see here. All right, and now we're going to hit enter. And let's try that again for the next. Equals, parentheses, observed, minus, expected, close parentheses, caret 2, so we'll square it, and then divide by the expected. Enter, and then try it one more time. Equals, parentheses, observed, minus, expected, close parentheses. All right, and then there we go. All right, so to get our critical value, you see the sigma here that looks like an E, means add them all up. So equal sign, sum, close parentheses, enter. So in order to know whether this final chi-square score is significant, meaning that, you know, there's a big difference or a significant difference between the scores within our groups, we need to look up the critical value that it needs to exceed. And we happen to do that beforehand, but in order to do that, you would need the chi-square distribution table. And you would need to know what the degrees of freedom are. The degrees of freedom are the number of categories minus 1. So we have 3 categories, you know, dislike, don't care, like. So that would be 3 minus 1 means we have degrees of freedom of 2. And if we're going by alpha 0.05, our critical value is 5.99. So our final chi-square far exceeded the 5.99, so we can reject the null hypothesis that these groups or categories are equal to each other. They're different from another. And we can calculate the p-value for this in Excel also by hitting equal sign, then typing this in this function you see here, CHISQ, whoops, test. So we look at we would highlight the actual range, and then put a comma, and then highlight the expected, and then close parentheses, and then hit enter. And our p-value is far below 0.01 even. And then we can calculate, we can test our outcome, in fact, because you can actually, you can calculate the chi-square test much easier too if you don't want to do it by hand. So here we have, let's see, oops. We had the p-value by, you can type in the chi-square, enter the probability, and then the degrees of freedom, which was 2, and then hit enter. And you can see we ended up with the same outcome, 58.05, by using the chi-square function that you see here. All right, that's how you would calculate a chi-square goodness of fit test in Excel. Thanks for hanging out with me. I'll see you next time.